Okay, guys, so, hey, listen up now. So next page. Okay, so at the moment we actually couldn't quite do problems like this. So what we learned last week was, well, we could try to make a substitution, but here there's no substitution we could make to make this simpler. So for example, if you try u equals x, this is no good, and if you try u equals ex, this is also no good. Okay, so we need another technique to do integration problems, and the reason this one isn't working, the reason it's so difficult, is because we are multiplying two functions together. This is what makes it difficult. So although we can do this, and although we can do this, we actually don't know how to do the two together. So this one's fine, but this one's not. So I'm going to show you a formula that will help us to simplify integration when we have two functions multiplied together. So let's scroll down now in a second. Okay, so scrolling down. Now, there's a couple of different ways to write the formula I'm about to show you. So the way I write it is the one that I find is easiest for most students, but if you've seen it before, you might have seen it written a different way. So the formula here is, if you want to integrate this, f derivative g, it's the same as fg minus f derivative g, like this. And the proof is really, really short and really simple. If I differentiate everything, the derivative here is f derivative g. This is product rule, so that's f derivative g plus fg derivative, and then this here, derivative and antiderivative cancel. So that cancels with that, that cancels with, yes, f derivative, I think I wrote something, oh sorry, I put my little dash on the wrong one here, that goes on the g. Okay, so now that one cancels with that one, and we're left with these two. So why is this formula useful? Because it looks like we start off with a multiplication and we still have a multiplication here. So I'll show you in an example how this makes problems easier. And then what I'll do is I'll just write this formula slightly differently in case you've seen it before. So if I go back to my example here of x ex dx, so this is the first example of using the formula here, and the formula is called the by parts. Okay, so if we have a look at the formula, I think the handiest way to do these is by just making a table, and here we have f derivative, g derivative. Now if we go back to the formula, you see in the formula it's f derivative g. So what that means is we call this piece here f derivative and we call this piece here g. So if that piece is f derivative, then that's x, and if that piece there, f derivative, yes, okay. If that's g, no, too early. Fix this again. Fg derivative equals Fg minus f derivative g. So make sure in the formula at the start the derivative's on the second one, and in the other side it's on the first one then. No, it doesn't really matter, but I want to match it up with what's going to be in the formula book so not to confuse people. But you're right, it doesn't matter. It doesn't matter at all. But like I said, I just want to match it up with the formula book for the exam. Okay, so now it's all fine. Alright, so going back here. Okay. Right, so here, this would be x squared over 2, and this one here would be ex, and then derivative of ex is ex. Okay. So that equals, so if we go back to the formula, you have fg minus f derivative g. So that equals f g minus I'm really sorry. I'm very tired this morning. I'm not well. No. I need to get this right. I can't remember which way around it is. Google's our friend. I think what I had 2 minutes ago, the other way around was right, but I'm not going to guess anymore. I'm just going to check. What's that? Derivative is on the second one, which is what I had. Yes, so it is right. I just copied these the wrong way around. Derivative is on the second one. Okay, everything is right now. Okay, so let me just do this again, but clearer. Okay, so the way we do these, you go to your question, and the first part of the question you call it f. So we put it in this box. And then the second part of the problem we call g derivative, and we put in this box. So we use this one and this one for the question. And then what we do next is we find this one and we find this one. Okay. So here I put x, that's f, and then g derivative, that's ex. So here's x first and ex next. X, ex. Okay. Now if that's f, then f derivative is 1. Yeah, derivative. And if that's ex, and that's the derivative, if I want the original, here's a derivative, so then this one here is a antiderivative. So what's antiderivative of ex? Ex, okay. Now the formula says, this is fg minus f derivative, which is 1, multiplied g. So what has happened is your formula has turned this problem into this easier problem. So we have this one to solve instead of the one up the top, which is easier to do because here it's just ex. So antiderivative of ex is just ex. Okay, I'll do some more examples. Okay, can I scroll down? Okay. So let's do x squared ex. Okay, so I'll make sure I get the order right. Fg derivative. So this is f, and then this is g derivative. So we make our table. F derivative, g derivative. So what goes in first here is x squared, and here is ex. So next, that's 2x, and then going up, that's ex. So we end up with this. So this table can help us to simplify again. So the formula is, this equals fg minus f derivative g. And if we look at this, we use it again. So it hasn't made it completely simple for us to do, but it has made it simpler, and if we use it again, it'll be simpler again. Why are you late, Joshua? No, too late, sorry. Okay, so we have to use it again. So another box. So f derivative, g derivative. So we're looking at this one now. So that is 2x, and then ex again. Okay. So that one would be 2, and then that one would be ex. Okay, so just be careful, because we're using the formula just on this piece of the back. So we need big brackets here, because I'm using it just on this piece at the end. F g minus f derivative g. So now you see I've used the formula twice and I've simplified it down into something we can do. So the answer would be x squared ex minus 2x ex minus 2ex. So then the answer is x squared ex minus 2x ex plus 2ex plus c. Okay, so let's have a look at an example that's a little bit more difficult. Oh no, actually, let me give you one to try. If I go down, yes? Now what's the antiderivative of log x? What is it? No, that's the derivative of log x is 1 over x. What's the antiderivative? No. We don't know. We haven't actually done it, believe it or not. But now, with this new technique from today, we can do it. What we do is, we imagine that instead of it being log x, I write it as log x multiplied by 1 dx. So now I can use my formula, and this one is called f. Yeah, and then this one's called g derivative. Okay, I'll give you a minute to try this and see what you get from the formula for this one. Okay, some people have an answer? What you get? Yes? Yes? Oh, it's halfway there. There's another piece missing. X log x, yeah?
Minus 1.
Oh, no. Did you say the antiderivative of 1 is 0? Good, okay. So x log x, yeah? I'm just missing a piece at the end, that's all.
You need to know the derivative of the length. Okay.
We know that the derivative of log x is 1 over x.
Yes.
Yeah.
So 1.
Yeah, so x log x.
Minus 1. Yeah.
Say with confidence. Yeah.
Minus 1.
Good, yes, okay. Good, so let's have a look at it. So here, f is log x, and its derivative is 1 over x. G derivative is 1. So what's g here? No. F, very good, yeah, because we go up antiderivative, down derivative. Okay, so the formula says this can be rewritten as f g minus f derivative g dx. Like that. So this is x log x minus antiderivative of 1, which is x. So it's x log x minus x. So it's x log x minus 1 plus c. And I'll assume that you have the brackets here, Ali. Yeah, I'll assume that, yeah. In the exam, I've seen this question, like this question comes up most years, but sometimes in the question they do this little trick on you, where they ask you to solve this, and they don't write the 1 in. So if you just have this, you think, well, what do I do? Do I make a substitution? No, that doesn't do anything. And you're supposed to recognize that you need to put a 1 in to make 2 functions so you can use the formula. There's not many functions they can do this with. I think your only possibilities for the exam is they could ask you for this one, like I just did, and then the sine inverse, the cos inverse, and the tan inverse. And the trick for all of them is to put a 1 in it to make it a second function. Okay, let's have a look at more examples. So,
That might have the equivalence for example.
yes, so in the exam it was a show question, like show that equals the other, yeah. But this one actually is not in the formula book, so it actually said this one would be a find, whereas these other three would be a show. Okay, let's have a look at another example now. So let's say we have x sine x dx. Okay, so that equals. So we make our table. Okay, so this is f g derivative. So that's f derivative, g derivative, and then what do I put here? Yes, minus cos x. So this was f derivative, and this one was g derivative. Okay, so this is equal to f g minus f derivative, which is 1, that's great, times g, which is minus cos x. So minus and minus is a plus. That's really good because we know how to do cos x. What do I get here for cos x? Antiderivative of cos x? Sin x. Yeah. Okay, now I think we've done plenty of examples where it's just straightforward using the table. So let's look at one that isn't as straightforward. So let's say sin x multiply ex dx. Let's see what we get here. So if we try to use our table, f derivative, g derivative, so that's sin x, cos x, ex. So it's f g minus f derivative g. Okay, so it seems like no big deal. We just have to use our table again, except on this piece at the back. So we try using our table again with the piece at the back. Yeah. What's that? Oh yes, we'll see the problem now and then how to fix it. F derivative, g derivative. So f is cos x, f derivative is minus sin x, and then we have ex, and again just be careful, I'm using this for the piece at the back here, so I'll put brackets around it. So here we get ex sin x minus with brackets, and then fg, so ex cos x minus f derivative, which is minus sine, so plus here, sin x ex dx. So what's happened now? Has it gotten any simpler after using the rule twice? No. In fact, what do you think is going to happen here each time I use the rule? Will it get any simpler? No. So it looks like we're stuck. We have ex sin x minus ex cos x minus sin x ex dx. And it looks like we're stuck. But there's actually a little trick here. We need to remember what the question is. The question is sin x ex, what does it equal? So can anybody spot the trick here to stop the loop and to get to an answer? Any ideas? Yeah. Take this here and move it to the left. You already have it on the left and you have it on the right. the minus becomes a plus, so in total you'll have two of them. 2 sine x ex dx equals ex sine x minus ex cos x. So if I divide by 2, I get sine x ex dx equals a half ex sine x minus cos x plus c. So all I did as well at the end was I took the ex out in front. See there, it is there. And also I divided by the 2. And not to forget my plus c as well. Okay. Right, let me give you one to try. Maybe not as difficult as this. I don't know. How difficult it is. Yeah, okay. I'll give you another one to try. Not quite as difficult as this. Try this one. Yeah, try this one. See what happens. No. Because if it was an exam question, you couldn't. Okay, so I'll do this one now for you, but I hope you can see as you're doing it, it's a little bit more difficult than maybe it seems like it should be. And in fact, I did this on purpose. I wrote it backwards to show you that the order you write it is very important. In fact, if I gave you this question to do, which is exactly the same, it's much, much easier to do, because the table it makes, if you look, f derivative, g derivative, so here this is log x, 1 over x, and then this is x power a half, so this one here would be increase the power by 1, and then divide by the new power. Okay. So you can see that this is a lot easier to do. F g minus f derivative g. So this is fg minus 2/3. Now this is like power 1 here. So 3 over 2 minus 1 is a half. Okay, so that can be done in one step. Increase the power by 1 and then divide by the new power again. Okay, so it's finished now. I'll just clean it up a little bit. I can take out the 2 over 3 and the x 3 over 2, and on the inside I'm left with log x minus 2 over 3 plus c. So the question now is there any way to remember or to know when it's a good idea to swap them to make it easier? Okay, scroll down a little bit. So when we have problems where we have f multiply g derivative, when do we know to swap these to make it easier? In other words, what should the order be between the two? So the way to remember it is by remembering this, Liate. So this means L for log. If you have a log, the log should be first before anything else. So this one here is log, like log x. This one here is I, stands for inverse, like sine inverse, cos inverse, tan inverse. This one here is A for algebra, which just means things like x squared, square root x, cube root x, whatever. T for trigonometry, so that's just sine, cos, tan. And then E for E. So you can see in the example I just had, I had an L and an A. So it means I should write my log in front of my x power term. So this is the correct order for it. Log first, algebra term second. Okay, I'll give you one to try now. That rule is not in the formula book, that's just a little trick to help you remember the correct order. So this is not in the formula book, it's just a little trick. Doesn't always work, but for the exam it should always work. Okay. I scroll down. So I'd like people to try this one for me, please. And the only extra step I'm going to add in for you is just to put limits in at the end. So you'll need your calculator for this. So give this one a try. have a look at it now. So I hope you spotted at the start the log should go first. So it should be written like this. We draw our table. So this is f derivative, g derivative, and so here should be a half x squared. f derivative, g derivative. Okay, so if we use our formula now, this is f g minus f derivative g. I can simplify this a bit. A half x squared log x minus a half x dx, because that will cancel with that. So this is a half x squared log x minus a half x squared over 2 plus c. I don't need the c actually, because I'm going to put limits in of 1 and 2. Okay, so if I put in 2 first, that would be 2 squared, which is 4 over 2, which is 2 log 2. Well, here's actually a 4. 2 squared is 4, 4 over 2 is 2, 2 over 2 is 1. Okay, now I put in 1. Log 1 is 0, so that's gone. So that would just be 0 minus a quarter. Okay, so this is minus 1 plus a quarter. Minus 1 plus a quarter is minus 3/4. So that's the answer. And often in the exam, they want the exact answer for these types of problems, integration problems in semester 2. In fact, if I think about it, I think 90% of the time they want the exact answer for all these integration problems in semester 2. It's kind of rare that they would not ask for this. So, how would you know this in the question? Well, if I go just back to the question, well, no, I'll just write it down here. The question might say something like to write your answer in the form of a log b plus c, or something like that. So don't worry if it says something like this in the question. What they really just mean is write your answer exactly. Okay, so like I said, there's different ways to write this formula, so I just want to write the different ways, just in case if you've seen it before, you can see which one looks familiar to you. Okay, so our way which we use is f g derivative dx equals fg minus f derivative g. That's one way. As you just saw online, some formula books or books would use u and v. That's not a big deal. But this can be written as u dv dx equals u v minus du dx v dx. Now, you can see that this is the same as this. All I did was replace f and g with u and v. Yes? That's all I did. So instead of f and g, I have u and v. But can you see that this is still the same, because all I did was replace v derivative with dv dx and u derivative with du dx. So they are all the same. But this last one here is the one that you have in the formula book. So I would say it might be helpful in the formula book, in the exam, to rewrite this, the u as an f and the v as a g derivative equals fg minus f derivative g. And the reason I use this one is just because it's a lot quicker to do, since I don't have to write dv dx every time. So can you write those three down? Okay, one more example, and then I'll let you try some in the book. Scroll down, yeah. Scroll down, yes? Yeah. Okay, so one more example. So something like this, sine squared x dx. So a lot of people might see straight away, here we have sine x dx. And you realise, oh, it doesn't matter which way around it is because it's the same. F derivative, G derivative. So here this is sine x, cos x, and then here this is sine x minus cos x. Okay, so we can use our formula. It is f g minus f derivative g. And the reason I squared it is because I'm going to get a cos x and a cos x, but actually that's a minus cos x, so I should change this to plus minus f derivative g. Yes, it's a plus then. So this equals minus sine x cos x plus integration cos squared x dx. Now something similar to earlier is happening here. When you use the formula, it doesn't get simpler. All we've done is change the sine squared into a cos squared. So what did we do last time that happened? Well, last time, yeah. Go ahead, yeah. No, last time we just used it again, and then we have to take something over to the right. But there's a little bit of a quicker way to do it, and I wonder if anybody can spot the slightly quicker way to take care of this problem of the cos squared. Any ideas? So I know on the left I have in the question sine squared x dx. Yes, what is it?
1 minus sine squared x.
Yeah, if I rewrite this instead as 1 minus sine squared x, it saves me having to do the integration by parts step again, because I have my sine squared take over now. So this will be minus sine x cos x, integration of 1 is x, and then this we don't know. But that's fine, because now we can add it to the left. I can now take this over to the left. So I have two of them. So I get 2 sine squared x dx equals minus sine x cos x plus x. So I end up with my answer, sine squared x dx equals a half x minus sine x cos x plus c. Was there some assignment due this morning? Which one? Chemistry was due this morning? Oh, 10 a.m. Okay. Is that why everybody's upset? No. You mean you weren't up all night finishing it? Oh, so it's not finished then?
No, it's finished. It's the first job.
Oh, just the first draft. Oh, right. That's the second reason too, yes. Okay, I'll let you try some of those for 5 minutes then.